Hello and welcome to another episode of Maskey TV. I'm so happy to have you here, grade 10s. We are going to be doing the topic of measurement today. Our lesson objectives for today is to just go through some facts about your three-dimensional objects, some right prisms and right cylinders as well. We're also going to do some calculations of total surface area and volume of right prisms as well as other 3D solids. We are also going to do some exam type questions. Are you ready? Let's go. Right, so some facts and some interesting information that we do need to know. This is three-dimensional solids. A solid is an object that is not hollow and has three dimensions, which we usually call your length, breadth, and height. As you can see, these are some solids over here, and many of them you know already or you've seen or heard of. It is your cube, or another one would be a rectangular prism. This is a triangular-based pyramid. This is a cylinder, a cone, and a sphere. The line of intersection of two planes. So let's have our rectangular prism over here just to explain what this sentence is telling us. The line of intersection of two planes is called an edge. So how does that look? We have two planes. So we've got the green one over here and the yellow one. The line of intersection would be this line over here, the intersection between two planes. This is called an edge. This is also an edge. That's an edge. And the point of intersection of three planes is called a vertex. So let's see our three planes. We've got our yellow plane, blue plane, green plane, and where the three planes meet is a vertex. We can also call this a corner. In a rectangular prism, we have 1, 2, 3, 4, 5, 6, 7, 8 vertices. We use vertices for plural. We can call it a corner or a point. What's important is to know the different things about a rectangular prism, which is a face. So we've got these faces here that are in colors. They are all rectangular faces, the edges and the vertices. They like to ask you questions about those three things when it comes to 3D solids. And now, grade 10s, we are going to look at the new solids that you may have heard of before, but we only do calculations with it in grade 10. So that is your spheres and your hemispheres. Now your spheres is a shape that is like a ball. I have a lamp over here with me, and this lamp, as you can see the top part of it, it is in the shape of a ball, and this is a sphere, like the planet Earth. And then half of that we call a hemisphere. So it's just half of a ball. If you chop a ball in half, it is called a hemisphere. The dimensions that is important for a sphere and hemisphere is the radius of the sphere, or the diameter, because we know that the diameter is 2 times the radius. Then we're also going to look at right pyramids and right cones. So this is a cone and this is a pyramid. The cone over here, you'll see it has one base and it is a circle base. And the dimensions that are important are a radius of the circle, the perpendicular height of the cone, and the slant height. Then we have our pyramid. It could be a rectangular-based pyramid, or it could be a square-based pyramid. And the dimensions that are important for your pyramid is that right angled triangle you can see over here. We have our height, we have our slant height, and we have this distance over here, which is half of this dimension on this side over there. So those are your new solids where we're going to be doing some calculations with them. And it's important that we recognize and we familiarize ourselves with the formulas of those solids. What is important is to remember our knowledge from grade 9 as well, and that is the right prisms and right cylinders. And so we must remember that all prisms always have a pair of congruent bases which are parallel to each other. So let's use my rectangular prism again, and the ones you can see on screen. So the ones you can see on screen, they have the shaded area, which is the bases. Okay, so I'm looking at my rectangular prism over here, and I'll use the blue rectangle, and the top, This is my bottom base and this is my top base. They are parallel to each other. Not only are they parallel to each other, they are congruent as well. They are equal in area. And then we also look at the other faces. This we call the lateral faces. The other faces, my green and my yellow, right? They are always perpendicular to the base. The base of a right prism is a polygon. A polygon is a 2D shape, like a square, a rectangle, triangle, or a circle. And so the base of a right cylinder is a circle. The base of a triangular prism is a triangle, and the base of a rectangular prism is a rectangle. And the other one that we know and love is a cube. A cube, the base is a square. All right, some formulae for the right prisms. The total surface area is always equal to 2 times the area of the base. Remember the pair base, top and bottom base, plus the sum of all the lateral sides. So it is the 2 times, so it's 1 base and my second base. They are the same in area, so we times them by 2, so the area of these 2. And then we add the area of the other faces, the lateral faces. That is the total surface area of any prism. That goes for all of these prisms over here. The volume is equal to the area of the base. So let's use our rectangular prism one more time. Okay, so the area of the base, so our base is a rectangle, so let's say it is length times breadth, and then it will be times the height. And the height is what makes it a 3D solid. So the area of the base times the height. That goes for, again, all 3 of these prisms as well as a cube. Okay, grade 10s, there is also an element in measurement where we might need to convert between centimeters to meters, millimeters to meters, and so forth. You need to make sure that all your units are in the same unit of measurement. So it all needs to either be in centimeters or in millimeters. And this is because when you are putting into the formula your dimensions, the dimensions need to be all the same unit of measurement. Otherwise, your formula will not work. So for example, let's just have a look over here. 1 centimeter is equal to 10 millimeters. So if I want to go from centimeters to millimeters, I'm going to times by 10. If I want to go from millimeters to centimeters, I'm going to divide by 10. Okay, grade 10s, we are now going to go into an exam type question. So this question came from the DBE paper 2018, paper 2, because measurement is in your paper 2. Let's have a look at this question over here. Question 6 of 2018 says, the diagram below shows a cup with a volume of 117 pi centimeters cubed and an inner diameter of 60 millimeters. It says ignore the thickness of the cup. Before we go to the questions, what do they mean by ignore the thickness of the cup? Well, first of all, if we have our cylinder, I think I'll take this as an example. So we have our cylinder here. This is just the inner part of a paper towel. And if this cardboard was very thick, right, then we would have to consider the space inside it or the volume inside it would be smaller. So they're telling you to ignore the thickness of the cup. For example, if it's a glass cup and it's 2 millimeters thick, we're ignoring that. Okay? It says calculate the height of the cup. So that's our very first question. Calculate the height of the cup. What do we know about the cup? Let's highlight what we know. And we know that the volume of the cup is 117 pi centimeters cubed and an inner diameter of 60 millimeters. Okay, so what do you notice about those dimensions or those measurements? we have centimeters, and we have millimeters. So now we need to convert from millimeters to centimeters or from centimeters to millimeters. We're going to convert the millimeters to centimeters because this is already a volume and this is just a dimension, which is the diameter of the cup. So this length across here is your diameter. So let's see, do you remember how to convert from centimeters to millimeters? Let's go back to our conversion table. And as you can see, if we're going from millimeters to centimeters, we are going to need to divide by 10. So 60 millimeters. If we divide that by 10, we're going to get 6 centimeters. So let us write there on our diagram, we have 6 centimeters is our diameter. But in order to use this question, we know we have the volume of the cup, and the cup is a cylinder. And a cylinder is one of the shapes, like your rectangular prism and triangular prism, where we actually need to know the formula for the volume off by heart. So the volume is 117 pi cubic centimeters, and the formula for volume is volume of a cylinder is equal to, remember what did we say? It is the area of the base times the height. What base do we have for a cylinder? We have a circle base. So if we have a circle base, it is the area of a circle, which is pi r squared, and we're going to times by the height. Okay, we already know what the volume of the cylinder is. We know it is 117 pi centimeters cubed. So we're going to substitute that into our formula for volume. And we also know that the diameter is 6. But when it comes to formulas of volume and circumference and total surface area, we use radius. So our radius is actually half our diameter. So we're going to take our diameter, which is 6. Diameter is 6. And therefore our radius is equal to half of that, which is 6 over 2. And so our radius is 3. So we're going to substitute our radius into the formula, pi r squared, and our radius is 3. The question is asking us, what is the height? And so we are going to find the height by getting the height on its own. We are going to make the height the subject of the formula. So we're going to divide by pi times 3 squared. Let's just simplify first. So we've got pi, 3 squared is 9. Let's rather write that as 9 pi. 9 pi times my height. So now I'm going to divide by 9 pi on both sides to get h on its own. So let's divide by 9 pi on this side and 9 pi on that side. Okay. Okay, so we're going to have height on its own, and we can see clearly that the pi's will cancel, and then we've got 117 divided by 9. 117 divided by 9 is in fact 13. Okay, so we've got our height of our cup. Now let's look at our next question. Our question says the total surface area of the water that touches the cup, if the cup is 80% full with water. That's an interesting question. I think that I'm going to let you guys think about that question just for a few seconds so that you guys can have a look at it, and we'll go through it together in a few seconds. Welcome back. Let's go through this question. So have you had a look at it? Have you started writing it down and trying to work it out? Well, let's go through it together. So it says the total surface area of the water that touches the cup. So we're talking about the surface area that of the water that touches the cup. And not only that, the water that touches the cup, the water is only up to 80% of the cup. So I think the best way to think of this is to imagine that my height has reduced. My height will reduce by 20% because the water is only filling up 80% of the cup. So if we think of it this way, we have our height is now going to be up to here, right, where the water will be, which is up to 80%, which means that we have to get 80% of our height. So let us use our height that we worked out earlier on and let us work out 80% of our height. So we're going to say new height. So we're imagining a new prism, a new cylinder, right, where the water is filled up until that, but the height is now less because they want the surface area of that height. So our new height is going to be 80% of our old height. 80% of 13, you can say 80 over 100 times 13, and you can work that out. I'm just going to grab my calculator. 80 divided by 100 times 13, that gives me 10,4. So that is my new height. My new height is 10,4. And now they want the surface area of that. Let's see if we can go back to our formulas for surface area. Remember, this is a general formula. The total surface area will be 2 times the area of the base plus the sum of the lateral surfaces. So we are busy with a cylinder, and a cylinder, like my cylinder over here, it has 2 circles, a bottom and a top, but because we're dealing with a cup and we're talking about the surface area that the water touches, we're going to think of it as an open cylinder. So we're not going to include the top circle. And let's have a look at our circles over here and our rectangle. Where does that come from? This is actually our faces of our cylinder. I hope that this, what I'm about to do now, works out with you. So this is the inner of our paper towel, and if we cut it open, so that's your cylinder. If we cut it open, what do we have? We have a rectangle, right? So that is our rectangle, and if I had a top and a bottom for it, then those would be my 2 circles, and that is the surface area that we need to calculate. So let us get our area of our rectangle, which will be length times breadth. We have our height. Our height is in, I forgot the unit of measurement. We changed millimeters to centimeters, so it is in centimeters. Right, this is our height, and this will be our length of our rectangle. Remember, it is our length. My rectangle looks like this, but this would be our length, because this is your circumference of your cylinder. All right, so we're going to use the formula for circumference, which is 2 pi r, and we should know our radius, which was 3. I think I'm just going to rewrite it. Radius is 3 centimeters. Height is equal to 10,4 centimeters of our cylinder. So we're going to exclude our top circle because it's going to be an open top. We're going to find the area of this and the area of that. Let's write it on here, 10,4, and our circumference is 2 pi r, so it's 2 pi times our radius, which is 3. Let's get our surface area. This is the surface area of the water. It's the surface area that the water touches. So it's going to be pi r squared, which is the circle, plus our length times breadth, which is height times 2 pi r. That's the formula. Let's substitute what we know. So we know our radius is 3 We know our height is 10,4. And again, our radius is 3. Let's just simplify quickly. We've got 9 pi plus, I'll simplify that side using a calculator. So we've got 10,4 times 2, 10,4 times 2 pi times 3. And on this side, I have 196,04 and 9 pi. So I'm going to add 9 pi to that. And so my final answer is 224,31. And because it is surface area, it is centimeters squared. Okay. All right. I was very lucky to have a look at Crack the Maths Code, and I took out a few things from it that would be helpful for this lesson. There was a whole lot more because they did go into the other formulas as well, the ones that we did previously, but I just pulled out the new ones. So your sphere, your hemisphere, your rectangular prism, they show you all the different types of pyramids as well, and then I've got my cone over there. So this is really great. We're going to use this back and forth for our next few questions, because this resource over here, there's quite a few formulas, is going to help us a lot. They even, just to note, they even show you what the formula is if we have a closed cone and an open cone, which is pretty good. Okay, we're going to do an exercise from Crack the Maths Code. It says, calculate the surface area and volume of the following closed solids. Round answers to 2 decimal places. So I've got a sphere and I've got a hemisphere. Now remember we said we're going to use the formulas for Crack the Maths Code. I'm not going to do both of them. I'm going to do, let's do the surface area of a ball and the volume of my hemisphere. Okay, so if I want to find the surface area of my ball here, what is my formula? So I just go here, my sphere is a ball, right? And I'll go to surface area. So let's write the formula down. Surface area of my sphere, let's write sphere. That's going to equal to 4 pi r squared. Okay, let's work out that one, or let's put the formulas all down. My volume of my hemisphere. So volume of my hemisphere. Okay, and that's going to give me, the volume of my hemisphere is, and it is a, let's just see, closed solid. It's a closed solid. So we're going to use the formula for closed hemisphere. So that's 3 pi r squared. So we've got, that's surface area. My apologies. We're looking at volume. So it is volume of a closed sphere. When it comes to close and open, the volume does not change, but the volume is, it is 2 over 3 pi r, 2 over 3 pi r cubed. My apologies. There we go. 2 over 3 pi r cubed. Okay, we've got our formulas. And now we're going to answer those questions. So the very first one, 1.1, I'm just going to do the surface area. So what we need from this is the radius to substitute into our formula. We've got the diameter, which is 10. So what do? We are going to halve the diameter to get our radius. So our radius is equal to 10 over 2, which is equal to 5, and it is in meters. We are now going to substitute that into our formula. So 1.1, our SA, our surface area, is going to be 4 pi 5 squared. All right, 4 pi 5 squared is 4 pi times 25, and that's 25 times 4, which is 100 pi. And we can leave our answers in terms of pi unless they say leave your answer to 2 decimal places, which is what they said. Please round your answers to 2 decimal places, so we will do as they ask. Otherwise, we have not answered the question. 314,16, and that is meters. We are dealing with surface area, so it is meters squared. Right, the next one is 1.2. 1.2. We are going to get the volume of a hemisphere. It's a closed hemisphere, so it's 2 over 3. So volume is equal to 2 over 3 pi, and we need R. And we are given R. R is 4 centimeters. So we're going to substitute R in there. It's 4 and it is cubed. 4 cubed is 64. So we're going to multiply 64 times 2 over 3 and then multiply it by pi. And they want it in decimals, 2 decimal places. So 134,04, and it is in centimeters. And it is volume, so it's centimeters cubed. Okay, what a lovely exercise on the sphere and the hemisphere from Crack the Maths Code. So let's go. There is the solutions as well. Very nice, colorful, lovely images. Going through it step by step, explaining it for you. Lovely stuff. We have another question which I picked out, and I thought it was actually quite a nice exam type question, or maybe a test question, and I thought we could go through that together as well. I want you guys to just read through the question, have a look at it, and see if you can figure out what's going on here just all on your own for a little few minutes, and then we'll be back soon. Welcome back, and we are going to go through this lovely question over here. I hope you have read through it and tried to figure it out. Let's look at the question together and read through it. So it says, a village hut is drawn below. It has a total height of 2,5 meters from the ground. The very first question asks us to calculate the height. So not the height, the total height, but the height of our, what is this? This is a cone. So they want the height of our cone over here. So I'm just going to redraw some information that's on here. As you can see, there is this right angle triangle over there. So you have the triangle. You have the triangle A, B, and C. Yeah, my B looks weird. A, B, and C. You have the angle here, which is 30 degrees. And we are looking for the height over here. We are also given that this length over here is 1 meter. So looking at that, using this information over here, how can we calculate the height of this triangle? Because that is exactly what it's asking. And if you thought, I can use trigonometry here, then you are absolutely right, because that's what you need to do. So I just want to quickly go over some trig rules, because I know that's not our topic at the moment, but this can happen. You can have integrated topics where we have trigonometry coming into number patterns. It happens in grade 12, grade 10s. We need to get used to this. It is fine. We can do it. So just a quick reminder of our trigonometry, and that is sa, ka, toa. And those are your trig ratios. And what do they mean? It means sine of an angle is equal to the ratio of the two sides, the opposite side over the hypotenuse. The ka is cos of an angle equals, for that angle, the adjacent side over the hypotenuse. And then toa is tan of an angle equals the opposite side of that angle over the adjacent side. So that is trigonometry in a nutshell. And we are going to use those ratio formulas to help us find the side H over there. So this is how I normally do it. What do you know? What are you looking for? So what do we know? We know the angle is 30 degrees. So we have the angle, right? Which is your theta, your angle, right? So we need either one other side here, an A or an H, and we can find the unknown side. So we have the angle 30. Let's just write in, with reference to angle 30, where's my opposite side, my hypotenuse, and my adjacent side. Now the hypotenuse is always opposite the right angle. My apologies, I did not fill in the right angle over there. It is always opposite the right angle, so this side is in fact your hypotenuse. The side opposite 30 degrees is the side over here. And the side adjacent, which means next to, is the side over here. So that is all the sides with reference to this angle. So what do I have? What am I looking for? I have the opposite side, 1 meter, right? What am I looking for? I'm looking for H, which is the adjacent side. If I'm looking for the adjacent side, I have the opposite side. Which trig ratio am I going to use? I'm going to use cos, because, not cos, whoopsie, I'm going to use tan. Tan is opposite and adjacent. We are looking for the adjacent side, we have the opposite side. Okay, so using tan of the angle 30 degrees, so tan 30 degrees is equal to my opposite side over my adjacent side, which is 1 meter, opposite side, over my H, which is my height, my adjacent side. And now what we're going to do is get H on its own. So the best way, I think, is to show you the steps. We're going to multiply by H on my right-hand side, and we're going to multiply by H on my left-hand side. And so we have H times tan 30. Remember, the dot represents multiplication. And we have 1 over there. To get H on its own, I'm going to divide by tan 30 on both sides. So H equals 1 over tan 30 degrees. And now all I have to do is use my calculator to get the height. So it's 1 divided by tan 30. Please remember that whenever you are doing trigonometry, it is important for you to have your calculator in degrees, and to make sure you've cleared your calculator, and so then it will reset and be in degrees. So H equals 1 over tan 30, and that will give me square root 3. Because they mostly want me to use decimals, I'm going to write it in decimals as well. So square root 3, or 1,73, and our unit of measurement is meters. We are dealing with a village hut, so it is in meters. Okay, that is our height of our cone. The next question says, calculate the total volume of the hut. So now we have to work out the volume of the cone as well as the volume of the cylinder. So let us work out the volume of our cone and the volume of our cylinder. Let me just write in the dimensions that I have. So the height over here is 1,73. It is 1,73. It is good to write and annotate on your diagram once you have units and measurements and dimensions. It really, really helps when working out further questions. Okay, so I'm going to calculate the total volume of the hut. Let's just quickly go back and look for the volume of a cone. Remember, the closed or open doesn't make a difference. So we have our cone over here. Again, this comes from the book Crack the Maths Code. There's so much cool things in here. There are some exam tips in here. Really, really great. So let us get our formula for volume. So volume is equal to, the volume is 1/3, it doesn't matter whether it's closed or open, 1/3 pi r squared times height. 1/3 pi r squared times my height. Okay, let's go back to our question because we had some dimensions there, and we need to find our volume of our hut as well as the volume of the cylinder. Remember the volume of the cylinder, so this will be your cone, volume cone. Volume of a cylinder, this is something that we must know out of our heads, and it is the area of the base. The base is a circle times the height. Okay, so we've got our formulas over there. We are going to add those volumes together to give us the total volume of our hut. Okay, so let's get started. Our volume of our cone. Volume of cone is equal to 1/3 pi, and our R is, well, our R is the radius of the circle base of our cone, which is 1 meter. So we've got 1 meter there, and that is going to be squared times the height. We're going to add our volume of our cone to our volume of our cylinder. I'm going to work them out separately. 1/3 pi times 1 squared. 1 squared is 1, so I've got 1/3 pi times height. 1 squared is 1, 1 times 1/3. And I have also my height. I forgot to include my height. So let's add our height in. We do, in fact, have that dimension, which is 1,73. And now we can take our calculator and work out our volume of our cone. 1/3 times pi times 1,73. And that is going to give me 1,81. That is my volume of my cone, and this is in meters squared. Let us get our volume of our cylinder. So our volume of our cylinder, shorten it, our cylinder is pi r squared, so pi r is the same radius because they share this top base, and it's the base of the cone. So that's 1 meter, so 1 pi r squared times my height. Now, the height of the cylinder is actually 2,5 minus the height of the cone. So let's just quickly write on the side there, what is our height of our cylinder, because we don't have that yet. So height of our cylinder, right, will equal 2,5 minus 1,73. Right? Does that make sense? We have this height over here already, which is 1,73. The total height is 2,5. So in order to get the height of the cylinder, I just take 2,5 and subtract 1,73. Let's go. We have 2,5 minus 1,73. And the height of my cylinder is equal to 0,77. And this is in meters. Right. Now we can add that in over here. So we have, let's just go up a little bit, pi r squared times 0,77. Let's get that dimensions and that volume. So we've got pi times 1 squared is 1 times 0,77. So that gives me 2,42, and that is meters. Oh, I see I made a small area. When we're dealing with volume, it is not meters squared, it is meters cubed, because volume is the space that the cone takes up, right? So we're going to add this area over here, this volume, to this volume over here. And when we add them, we'll get the total volume of the hut. So total volume of my hut is equal to 1,81 plus 2,42. So 1,81 plus 2,42. That gives me 4,23 meters cubed. That is our volume of our hut. Okay. Let's see what we have next for you. Again, this is your solutions in your Crack the Maths code. this book, I'd like to maybe show you. I don't think you'll be able to see it, but the tips in here, I don't think you'll be able to see it, but maybe get yourself a copy and you can have a look and see. I've got one more question here, question 7, 2, 4, 6. I'm not sure if we'll have time to cover all of it, but let's go for it. So the diagram below shows the cross-section of a solid. Okay, cross-section, I'm probably going to get asked, what's a cross-section? It's basically if you cut a 3D object in half, it's the viewpoint that you see when you cut it in half, right? Okay, so the cross-section of a solid, this solid is made up of a hemisphere, so half is a sphere placed on top of a right circular cone. So this is a cone and a hemisphere, with a radius r and a slant height of s. The perpendicular height of the cone h is 6,5 centimeters, and the volume of the cone is, so they give you the volume of the cone is 83,38 centimeters cubed. Okay. Calculate calculate to the correct decimal places the radius r of the cone. Okay, so we need to calculate the radius. Before we do that, let's put some stuff that we know on our diagram, because I think that's going to help us. We know that the height is 6,5. So this dimension here is 6,5. And we have the volume of the cone, which is, the volume of the cone, which is this shape over here, right? Okay, which is 83,38. And we also have the formula for the volume of the cone, which uses height and radius. So if we want to find the radius of the cone, we can use the formula for volume, because we have the volume and we have the height. Therefore, we should be able to find r. Let's get started. So volume of cone, the formula is 1/3 pi r squared times your height. And we already know our height is 6,5. So r squared times our height is 6,5. We know our volume is 83,38. Okay, so now what we're going to do is we're going to divide by whatever is being multiplied by r squared. So that is 1/3 pi and 6,5. I think I'll do it quickly in stages. So we're going to say 83,38 divided by 1/3 pi. And that should equal to r squared times 6,5. Okay, let's not take that away without showing you the steps. So we've got 1/3 pi r squared times 6,5 divided by 1/3 pi. So what happens here is 1/3 pi will cancel, and we will be left with r squared times 6,5. So let's go up. So on this side we have 6,5 times r squared, and on this side I need to use my calculator to work that out for us. So 83.38 divided by 1/3, 1/3 times pi, shift pi. Let's go. We get 785,84. That's what I've got here. And then all I need to do is divide by 6,5 on both sides, and I should get my radius squared. So let's go. Divide by 6,5. I've got 120,89. That rounds down to 90. Okay. And that will cancel, and I've got r squared. So now what do we need to do? We need to square root both sides. Remember, usually when we square root both sides, we say plus or minus, but in this case, we're dealing with a dimension, so it has to be positive. So let us square root our answer. So square root of 120,90 gives me 10,99 equals my value for r. Okay. I don't think we have time to find the rest of the questions. However, you are welcome to go and have a look at those questions and work through it on your own. I'm so happy that you joined us today at Maskey Miller Learning and Maskey TV. Please remember to subscribe and like so you can get all those updates. as well as join Masky on the WhatsApp line 072 091 0388. Thank you so much for tuning in today. I hope to see you again next week. Bye.
And now we enter our next exciting chapter with the launch of Maskyverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.